Hi there, I'm Joe Burke. I'm going to be answering this student word problem today. When students solve word problems, they often find that they miss important information. They get distracted by extraneous information, and they will often end up answering the wrong questions. And so the strategy I'm going to model today is reading the question very carefully so that these things are less likely to happen. Now, in this particular word problem, there isn't a lot of distractors, but it is still a good problem we can use to model reading carefully. So the way I do that is I read the problem 3 times. The first time I read it through like a novel. The second time I read it through looking for key information. The third time I read through and I'm looking for what's being asked. So first time through. If there was 171 dogs competing and 87 competed in the first day, and twice as many dogs competed on the second day than on the third day, then how many dogs competed on the second and third days? Okay, we've read it through once. Now, the second time I read it through, I'm going to be looking for key relevant information. So the first thing I see is that there were 171 dogs competing. That's important. And then I see that 87 dogs competed on the first day. All right, that's also important. And then I see that on the second day, there were twice as many dogs as on the third day. And this too is important. We can use those 3 pieces of information to create 3 equations. It's important that we have as many equations as we have unknowns in any system of equation problems, like this particular problem. And so the final time through when we read it, I'm going to be looking for what's being asked. What is being asked? What is the unknown? And in this case, there's more than one. It says how many dogs competed on the second and the third days. We don't want to lose track of the fact that we're being asked 2 separate questions. Okay, so how are we going to go about doing this? Well, I'm going to share my screen with you, which will allow me to, you're now seeing my view of the screen, which will allow me to use the equation editor, and you'll be able to see as I'm forming equations. So the first realization we have is that the total number of dogs is equal to the sum of the dogs in the competition from each of the days. Now this is assuming that dogs do not compete in more than one day's competition, which is the only assumption we can make in order to solve this problem. Otherwise it's unsolvable. So here is our first equation. Now we're going to take some of our given information and we're going to draw some conclusions. First of all, it says that the total number of dogs is equal to 171. Second of all, it says that on the first day there were 87 dogs. So on D1, that's 87 dogs. And finally, we've got the number of dogs on the second day is twice as many as the number of dogs on the first day. So we'll say the number of dogs on the second day is equal to twice the number of dogs on the third day. Okay, now we have more than enough equations, and we should be able to create a single equation with a single unknown using this. And we're going to do that by substituting these equations here into this equation right here. So I'm going to grab that and, well, let's copy it, paste it, and then I'll edit it so that we don't lose track of where we were to begin with. The first thing we know is that the total number of dogs is equal to 171. We also know that on day 1, there were 87 dogs. And we know that on day 2 is the same thing as twice day 3. So now you can see that through substitution, we've created an equation, a single equation with a single unknown. And so we can now take this equation and solve for D3, which is one of the two questions that this word problem poses. So I'm going to edit this and solve it now. So we can combine this term into D3. And we can get rid of this. And we can move the 87 to the right. We can subtract 87 from both sides. In order to do that, and then 87 disappears from the left side of the equation, and the right side of the equation simplifies to 84. We can divide both sides by 3, and then this simplifies to 28. And of course, D2 we knew to be 3 times D3, and therefore we could say it was twice D3. And so D2 is going to be 2 times 28, which is 56. And so now, well, I unfortunately erased our intermediate equation, but there we have it. We've got our answer that D3 is 28 and D2 is equal to 56 dogs. So I hope that helps very much. Have a great day.